Hello, welcome. We are in Unit 10 and we're going to start off with Lesson 10.1 where we're going to learn our three trigonometric ratios and start talking about finding missing sides of right triangles. Now, trigonometry is its own type of math. You might think it's geometry, it's probably not algebra in mind, but trigonometry is really its own type of math. When we learn about trigonometry, trigonometry is the study of right triangles. Now, because this is about triangles, you might say this fits better in geometry. However, this is a really common topic on the PSAT and the SAT, so we like to review it again in Algebra 1 as well. Now, as we jump into our ratios, there is one really important word that we do want to be familiar with, and that is the hypotenuse. And so we do want to know what the hypotenuse is. The hypotenuse is the longest side of a right triangle. This is also known as the side opposite the right angle. The reason I don't always like to think of this as the longest side is because sometimes it can be hard to tell just by looking at the picture which side is the longest side. So thinking about it as the side opposite the right angle, that can be kind of a default way to always be able to figure out the hypotenuse, no matter what your picture looks like. All right, we're going to go through our three ratios and talk about an abbreviation for each, the ratio itself, and then look at an example. Later on, we'll get into some actual numbers and putting numbers with these things, but do you want to just kind of give us some familiarity with each ratio to start? All right, our three ratios are sine, cosine, and tangent. Hopefully these sound familiar to you from learning them in geometry. We'll go ahead and start with sine. Sine is the ratio of the opposite side to the hypotenuse. So there's two sides we're kind of looking at for sine. It's going to be the opposite side and the hypotenuse. Those will be two of the sides of the right triangle. Our abbreviation for sine is the first three letters, S-I-N. When you see S-I-N, that means sine, not sin, but if you say sin, that's okay. So this will be the sine. Our ratio, when we're setting up our ratio, and this is true for all three ratios, we are going to be taking the sine or the cosine or the tangent of an angle. This symbol here is our symbol theta, and theta represents an angle. So that's really important that we remember that we're always looking at an angle. So one of the angles in our right triangle is going to be that angle that we're looking at. And the sine of the angle is equal to the opposite side. I'm just going to abbreviate OPP over the hypotenuse, and I'm going to abbreviate HYP. So this ratio, this equation will be really important. The sine of the angle is equal to the opposite side over the hypotenuse. Now, this is all kind of arbitrary unless we have a picture that we're looking at. So we're going to go ahead and find the sine of an angle here. I'm going to start by looking at the sine of angle A. So if I'm looking at angle A here, this is my angle A. So this would be the angle. I'm going to label that with my theta symbol. This would be the angle that I'm looking at. This is angle A right here. Now, the first side I like to find is the hypotenuse. The hypotenuse is the longest side. It's also thought of as the side opposite the right angle. So if I go across the right angle, that's going to be the hypotenuse, and I'm just going to put an H there. Now, our other side that we're looking for is the opposite side. And the opposite side, I'm going to use a pencil to label this because it's going to change when we change angles. If I go opposite my angle that I'm looking at, this was the angle, we were looking at angle A. So if I go opposite that angle, that's going to make this side here the opposite side. So to set up the sign, we're going to set up a ratio, or in other words, a fraction, and it's going to be the opposite side. The opposite side was a over the hypotenuse, which was t. So that would be a over t. Now, if I change angles, and if I look at angle B, what that means is the opposite side will change. Now, the nice thing is the hypotenuse doesn't change. So now if I go and I look at side B, and I think of angle B as my theta, and if we go opposite that, opposite angle B here, this would become my opposite side. So now B is my opposite side. And sine is opposite over hypotenuse. So if I do opposite over hypotenuse, that would be B over T. If you're a little confused, just hang in there. This will make a little bit more sense once we start adding some numbers in. All right, cosine. When we talk about cosine, cosine is the ratio of the adjacent side to the hypotenuse. So cosine, we're going to abbreviate the first three letters, again, COS. If you say cos or cos, that's really just indicating the cosine. And the ratio is going to look really similar. We're going to have the cosine of that symbol theta, which again, that represents our angle. Again, we're always taking the sine or the cosine or the tangent of an angle. That's going to be equal to the adjacent side over the hypotenuse. So this is going to be equal to adjacent, which I'll abbreviate AGJ, over hypotenuse. Now, adjacent means next to. So when I think of the adjacent side, I'll think of next to, whereas opposite was more across from. So adjacent, I'll think next to. Once again, our hypotenuse is not going to change. The hypotenuse is the longest side. It's the side opposite the right angle. So I'm going to start by labeling that first. That's the hypotenuse. And we'll go ahead and find the cosine for each of our other angles. We'll start with angle A. And so I'll think of this as theta. This is my angle that I'm looking at. We want the adjacent side, or the side next to. Now, technically A has two sides next to it, this side here, but we've already called this side the hypotenuse. So this is not going to be my adjacent side because it's already the hypotenuse. Then this would be the other side next to angle A. So this side is next to it and this side is next to it. We're going to take the side that's not the hypotenuse, and we're going to call that our adjacent side. So if cosine is adjacent over hypotenuse, then our cosine here would be the adjacent side, which was B, over the hypotenuse, which is T. And we'll do the same thing for our other angle. So angle B, I'm now going to think of angle B as theta. Again, if we want adjacent over hypotenuse, adjacent is next to. So that's going to be this side. Again, it's not the hypotenuse because we've already claimed that as the hypotenuse. So this would be my adjacent side. So if we did adjacent over hypotenuse, that would be A over T. All right, and our final ratio is tangent. Tangent is the ratio of the opposite side to the adjacent side. So again, we're using those same sides we've seen before, just a different combination of them. So now we're we're setting up opposite and adjacent. Our abbreviation for tangent, again, is the first three letters, so that's going to be TAN. Again, if you see that and you say tan, that's okay, but tan just really represents tangent. All right, our ratio is going to look really similar. We're going to be taking the tangent of theta, which again represents our angle. As I've said, we'll always take the sine or cosine or tangent of an angle, and that's going to be equal to the opposite side over the adjacent side. If we want to find the tangent of our two angles, again, the hypotenuse stays the same. That's always the longest side, side opposite our right triangle. Let's take a look at angle A to start, and we'll see if we can figure out our two sides. So I'll think of this as theta. Now we need our opposite side. So our opposite side from angle A is little a. That would be the opposite side. And our adjacent is the side next to. Again, we already claimed the hypotenuse. So opposite is across, adjacent is next to. So if we do opposite over adjacent, that would be A over B. Again, I'm using a pencil so I can erase these because when we switch our angles, our sides will also switch. If we go and look at angle B now, and if we think of this as theta, we'll want to find the side opposite angle B. The side opposite or across from angle B would be side B, so this becomes the opposite side. And then the adjacent side would be side A. So that ratio, opposite over adjacent, would be B over A. So really, as we're identifying these ratios, we want to be able to find what's the hypotenuse, what's the opposite side, and what's the adjacent side in order to set up our ratios. Now, one of the things that is helpful to help us remember this is this phrase, SOHCAHTOA. You've probably heard this before. This is SOHCAHTOA, and this just helps us remember our ratios. Some of my students like to write it as this, so they write SOHCAH and TOA. That way they kind of remember the ratios themselves, the O over H, A over H, and O over A. But really what these are representing are those three ratios that we wrote. So this is basically saying the sine of some angle is equal to the opposite side over the hypotenuse. This is sine, opposite, hypotenuse. Ka is our cosine ratio. So cosine, the cosine of an angle, is equal to A over H. That's adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And the TOA is our tangent, so that's the tangent of some angle is equal to O over A, so that's tangent is opposite over adjacent. So writing that on your paper can really just be helpful to help us remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, we're going to take a look at just a few examples of how we actually use these ratios when we have numbers involved, because obviously numbers are a little bit easier to work with than just random letters. We're going to find each of our ratios, so we're just going to set up those fractions. I'm going to go ahead and start with my angle A. So I'm going to go ahead and look at my triangle, and I'm going to label things based on angle A. So this is assuming that angle A is theta. So if angle A is my angle, I want to find my three sides. I always like to start with my hypotenuse. That's your longest side, or the side opposite the right angle. So I'm going to label that H. The opposite side is the side across from the angle we're looking at. So if we're looking at angle A, that would make 5 opposite. And that leaves 12 as my next side, which is adjacent. Now, using SOHCAHTOA, sine is opposite over hypotenuse. So for sine, I want the opposite side over the hypotenuse. That would be 5 over 13. Cosine is the adjacent side over the hypotenuse. So I'd want the adjacent side over the hypotenuse. That would be A over H, which would be 12 over 13. And tangent is the opposite side over the adjacent side, O over A. So we would do 5 over 12. So this is really just looking at 1, can you label your sides correctly? And 2, do you remember your ratios? So sine is what over what, cosine is what over what, and tangent is what over what. We'll take a look at the same thing, but now we'll look at angle B. So I'm just going to erase this to start over from angle B. I didn't really need to erase my hypotenuse because my hypotenuse doesn't change. Again, that's still the longest side. Now if I'm looking at angle B as theta, my opposite side is across from angle B. So 12 becomes the opposite side. And then adjacent is next to, so 5 would be adjacent. If we set up sine, sine is opposite over hypotenuse, so that would be 12 over 13. Cosine is adjacent over hypotenuse, so that would be 5 over 13. And tangent is opposite over adjacent, so that would be 12 over 5. All right, in order to do our last type of problem, we do need to be able to type these on our calculator. So we're just going to briefly go through how to evaluate these on our calculator. It is pretty straightforward, but if you have a graphing calculator, you do need to check one setting on your graphing calculator. So I'm going to walk through this. If you have a scientific calculator, you can just skip this step because it won't be an issue for a scientific calculator. On your graphing calculator, you need to go to the mode button. Mode is at the top. And the third option says radian or degree. If your calculator currently has radian selected, so if it looks like this, you'll get the wrong answers for all of these problems. So what we need to do is we need to go over and just select degree. So you can use arrows and press enter. Once you change this once, you shouldn't need to change it again unless you reset your calculator for some reason, but it does need to be in degree mode or else you'll get the wrong answer. So again, to get there, I just pressed the mode button and then made sure that this third option said degree. All right, typing these is pretty straightforward. You should have a sine, a cosine, and a tangent button. Even on a scientific calculator, you should have those as well. So to type in the tangent of 26, I'm just going to type in tan 26 and press enter. We're going to get in the habit of writing 4 decimals, so I'll say that's 0.4877. The sine of 49, again, you should have a sine button, so we can press sine and type in 49, and I'm going to write down 4 decimals, so I'll say 0.7547. And cosine of 100, negatives are okay, so I'm going to say negative 0.1736. So I would just make sure you get those same things when you type them on your calculator. Again, just make sure you're not working in wrong mode. All right, we made it to our last type of problem, and that is finding the missing side. And this is really where we've been heading, is to be able to use these ratios in order to find a missing side. Now, the first thing I always start with is I always start with labeling my sides. So this is the angle that I'm given, so I'm working from that 38 degrees. I like to start with my hypotenuse. My hypotenuse is the side opposite the right angle. And then if I think about how this side x relates to the angle that I'm given, it's across from, and across from is opposite. I don't know anything about the adjacent side. This would be my adjacent side, but I don't really know anything about that, nor am I trying to find it at all. So that means I'm just not going to use the adjacent side as I solve. Now, I need to pick one of my ratios. So I either need to pick sine or cosine or tangent, and that's going to be depending on what I'm given. Because I'm given O and H, I want to use the ratio that uses O and H. So I'm going to pick the sine ratio because sine uses O and H. And then we're going to set up our equation. we're always taking the sine or the cosine or the tangent of an angle. So I'm taking the sine of my angle. That's equal to opposite over hypotenuse, right? Sine is opposite over hypotenuse. So that's going to be x over 10. So this is pretty much what our equation is going to look like, and then we just need to solve this equation. If I wanted to get x by itself, here I'm dividing by 10. To undo dividing by 10, I could just multiply both sides by 10. And then this is what I could type on my calculator. So on my calculator, I could type in 10 times the sine of 38, and this will be my answer. On your practice, I believe it has you round to the nearest tenth. So for my answer, I am just going to give 2 decimals, or 1 decimal. I know I said before write 4, but I'm just going to go ahead and write 2. That way you'll kind of practice what your homework is going to look like. So I'll say 6.2 will be my x value. All right, last example. Again, I'm going to start with my angle here. So this angle is 57. We'll label our hypotenuse. Our hypotenuse is the side opposite the right angle. The side across from 57 is my opposite side, but again, I'm not given a number here or a variable, so I'm not going to use the opposite side, and that makes 4 my adjacent side, because this is the side next to 57. Again, I'm going to want to pick one of my ratios, and that's going to depend on what I'm starting with. So if I look at what I'm starting with, I have an A and an H. A and H is going to be cosine. So I'm going to use the cosine because that uses A and H. And I'll set up my equation. Again, we're always taking the sine or the cosine or the tangent of our angle. So that angle is going to go next to cosine. Cosine is equal to A over H. So A over H, that's going to be 4 over X. You'll see that sometimes X is on top and sometimes it's on the bottom. If X is on the bottom, I can't just divide by 4 or multiply by 4. What I need to do first is I need to actually move my X first. That might seem counterintuitive, but we can't solve for X. We can't solve for X if it's in the denominator, so I do need to move X at the start. So if I move X, we get X times the cosine of 57. And now if I wanted to undo that, I'm multiplying by the cosine of 57, so we could divide by the cosine of 57. So that's what I could type in my calculator. I could type in 4 divided by the cosine of 57. And again, I'll go ahead and give just 1 decimal, so I'll say 7.3.